Hello and welcome to Train Signal. You're watching Cloud Computing 101. In this introductory lesson on cloud computing, I'll start off by answering the question, what is cloud computing? And it may be a more difficult question to answer than you might think because cloud computing means so many different things to different people. From there, I'll delve into the various forms of cloud computing. I'll cover cloud terminology, how cloud requires a new approach to information technology. I'll cover private, public, and hybrid cloud. I'll discuss common concerns around cloud computing, what makes up an infrastructure as a service cloud, and how cloud is related to virtualization. We've got a lot of great things to talk about, so with that, let's get started. This is a quote from 1977 by Ken Olsen, president, chairman, and founder of Digital Equipment Corporation, or DEC, maker of big business mainframe computers, arguing against the PC. The funny thing is, of course, DEC was later bought by Compaq. Compaq became HP. And what Ken said at the time is, there's no reason anyone would want a computer in their home. And why is he saying that? Well, he thinks that the big business mainframe computer is going to be the solution that everyone's going to choose. That big business computer is going to be, somewhere maybe at the company's data center for the employees, but potentially even, somewhere out in the cloud, let's say, somewhere else that people are accessing remotely. So he's picturing remote people, even, let's say, using those big mainframes from home, I'm picturing. So they don't really need a computer in their home. They don't need a personal computer. And I think things have gone full circle in the IT industry where we went from having mainframes back then, and of course the PC, gained tremendous popularity. Every person had a PC on their desk and a laptop in their bag that they took with them. And now things are starting to swing back the other way to more centralized forms of computing with thin client computing and desktop virtualization, and even now cloud computing. So cloud computing takes what virtualization does, and if you're not too familiar with virtualization, that's okay. We'll be jumping into that here in a minute. Cloud computing takes virtualized desktops and servers and provides you access to those, in many cases, over the internet. And it might not be just a desktop that you have access to. It might be a particular application that you use or you're even already using as we speak. So I think it's funny if you look at this quote, back 10 years ago it seems ridiculous, but now it's almost coming full circle, and people are less and less likely to have a full computer in their home. They might be able to get away with a thin client device and use desktop as a service, which we'll be talking about. They might be able to get away with just an iPad or an Android tablet and access all their applications out on the internet and use software as a service. So now coming full circle, maybe it is that Ken Olsen was actually right back in 1977, where end users eventually won't have a full desktop computer in their home. Now, I'm a big Dilbert fan, and I just love Dilbert jokes, and this one is particularly funny because it's related to cloud. So, of course, you can read it yourself, but I'll give you a little interpretation of it here. The pointy-haired boss hires a consultant to help them move to cloud computing. All the consultant says is blah, 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 cloud, 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 cloud. And the pointy-haired boss says, it's amazing. You're like a technologist and a philosopher all in one. And the pointy-haired boss says, let's implement cloud computing. So I'll have something to talk about at the executive meetings because they like that buzzword cloud. And Dilbert says, tell them we're evaluating it, and that way neither of us has to do any real work. And the pointy-haired boss says, I like it when you do real work. And Dilbert says, sorry, I thought you were leading by example. And the moral of this joke is that so many executives are guilty of being like the pointy-haired boss here and jumping onto the cloud computing bandwagon both feet first without ever even looking or thinking to consider what cloud computing can really do for them and how it's going to provide real business value. Because, honestly, today cloud computing may not be right for everyone. You need to look at it on a case-by-case basis and make sure that you don't fall victim to the tremendous marketing hype related to cloud computing. This is a great graphic from text24by7.com. It shows that you can put so many things into the cloud, everything in the kitchen sink. You see the database, the app server, the codes in the cloud, mobile devices, PCs, and yes, even the kitchen sink icon right there has been put into the cloud. So let's not fall victim to the marketing hype and jump into it before we fully understand it. You don't want to throw the kitchen sink into the cloud. It just may not make sense. And before we move on, I've got one more joke here. The two guys look at their whiteboard and they've got all these business processes, and they say, last year we recognized our processes were far too complex here in the business. So we put them in the cloud. So they drew a cloud there. There's a big question mark. They don't know what's inside. It all goes into the cloud and it just comes out. And that's really idealistic, sort of utopian. And in some cases, the cloud can simplify your business processes. But if you have poor business processes, in many cases, the odds are the cloud can't help with that. You just need to improve your business processes. Now, there are a lot of things the cloud can help with, and that's what we'll be talking about, of course, in this course. So let's start off with a definition of cloud computing. Now, this is from VMware, who's one of the largest cloud computing software companies in the world. They say that cloud computing is an approach to computing that leverages an efficient pooling of an on-demand, self-managed virtual infrastructure. So let's break this down for a second. So you're using a virtual infrastructure, and if you're not familiar with virtualization, that's okay, because we'll be talking about how it relates to cloud computing in a little bit. But virtualization, just think of it as a layer of software on top of physical servers that make those servers more efficient. So you've got a data center with servers. You've got a virtual infrastructure software layer on top, and then you're using something on top called cloud computing, let's say, that's going to help you to pool those resources, allow them to be available on demand to the business that needs them or the person that needs them when they need them, and it's all going to be self-managed. So that person or that business can create their own virtual data centers and virtual machines and applications and scale it out to as many end users as they want whenever they need to, and they're only going to pay for whatever they use. So this is commonly infrastructure as a service cloud computing, but many of the words here that we're using to define it are the same no matter what type of cloud computing you're talking about. The pooling, the use of virtualization, on demand, self-managed, all these things relate to really any form of cloud computing. I believe VMware was talking about infrastructure cloud computing here with this definition, but again, the terms are very similar. So that's just one definition of cloud computing, and this one happens to be from VMware. Let's try to define cloud computing a little bit more. Cloud computing actually abstracts the business services from the underlying complex IT infrastructure. So if we think about that, you've got this big data center, or your service provider has a big data center. It's a complex IT infrastructure. You know, the business, they really don't care about how complex it is, what's in the data center, the speeds and feeds of the servers and the storage and the network. They just want to do their business. They want to use the applications they need to service their customers and make money. So cloud computing takes away the complexities of the underlying infrastructure and gives the business the services that they need. Now, it uses virtualization and a pool of virtualized resources to do it. The business can consume those services and those applications on demand whenever they need to, however much they need to, just like a utility. For example, you don't go out and buy your own, power plant. You don't buy a huge block of, kilowatts of electricity from the electric company. You just pay for however many kilowatts or whatever unit it's measured in. You just pay for however much electricity you use, right? It's a great way to consume that type of utility because there's no commitment. You just pay for whatever electricity you use, just like you pay for whatever water you use. Or let's say you, for example, rented a car. You might pay for however many miles you drive. So these are forms of utility services, and cloud computing is very similar in the sense that you're going to pay for whatever you use. You're going to pay by some computing unit, or you might just have a flat rate monthly service so that you can use up to so much. Now, this way, cloud computing is able to give the business and the users what they need when they need it without those people having to worry about the underlying complex IT infrastructure. They don't care when they add 100 new users that 100 new desktops have to be added and rolled out, and software has to be installed, and licenses have to be paid for. All this can be abstracted away from the business, and the business just gets exactly what they need, the applications to service their users or their customers and make money. And now let's delve into the various forms of cloud computing. So, as I mentioned before, cloud computing is some sort of hosted service. It's something you're paying someone else to do for you out there on the internet. And there's different types of services, of course, that you might want to pay them to do. So, one could be infrastructure as a service, or IaaS. So, with infrastructure as a service, you're actually paying a service provider or a cloud computing company to provide you the infrastructure that you would normally have in your data center, and then they're selling it back to you as a utility service, so you pay based on how much you use. So infrastructure as a service typically provides you a individual virtualized server, let's say, that you can use, and then you pay based on how many CPU cycles, how much memory, and how much storage that virtual machine is using. So you might want to use that server, let's say, to host your company's e-commerce application out on the internet. You might want to use it for email or some other web application, let's say, that's facing the internet. Or you could even connect it back to your own internal network, let's say using a VPN, and actually use that virtual server along with your existing data center services. So no matter what, you're paying them for that infrastructure, and they're actually providing it to you in a self-service manner. You might be selecting the virtual machine out of a catalog so that you can very quickly get this virtual machine and its applications up and running in just a few clicks. Infrastructure as a service makes bringing up new servers super easy. Then there's platform as a service, or PaaS. With platform as a service, a cloud computing company is providing you a development platform and the resources for you to make your web application available to people out on the internet. So let's say that you had an idea to create a Java application. You create this Java application, but hey, you need to distribute it and you need to provide access to it, and it needs a back-end database. So many things are involved in getting this application out into the hands of people and allowing them to use it. You really need some sort of delivery platform, and that's what Platform as a Service does, or PaaS. Then there's Software as a Service. Now, chances are, whether you know it or not, you're already using some form of software as a service. So with traditional software, if you think about it, you would go to a store, you'd buy it on a shelf in a box, you'd bring it home, you'd put the disk or the CDs into your computer, you'd load it up, and you own that software, and you can do whatever you want to do with it, and you can use it forever. That's how traditional software was sold to people. With software as a service, you don't download anything, you don't go and buy anything, you're accessing some software as a service, most likely through a web browser. So you just open up your web browser, you go to a website, you're using some software. It could be free, or you could be paying them based on how much you use it. Maybe a flat monthly fee or yearly fee, or maybe based on, let's say, how much storage you use or how many emails you send. Examples of software as a service would even be like Gmail or Hotmail or Yahoo Mail, or even, let's say, something like Dropbox, a file sharing service. Just about any software that you use today over the internet that you're not downloading and installing, any software that's in a web browser, usually that you're paying someone a subscription to use based on your usage or however many people in your company are using it, that's software as a service. And there's so many different forms of software as a service. But the main difference between traditional software and software as a service with cloud computing is with traditional software, you're buying the software, you own it, you can use it forever. With software as a service, you're paying someone a monthly fee. You don't actually get that software, and you can't use it typically if you're not connected to the internet. So those are the three most common forms of cloud computing: infrastructure as a service, platform as a service, and software as a service. By the way, there's so many other forms of cloud computing and other types of infrastructure as a service that aren't listed here. Things like storage as a service, desktop as a service, disaster recovery as a service, IT as a service. There's a long list of these services delivered through cloud computing, but these are by far the most popular and most important forms of cloud computing that you need to know about. And we'll be delving into each one of these in this video training course on CompTIA Cloud Essentials. Now here's another way of looking at those same types of cloud computing services. On the top, you've got software as a service, which is being provided to end users or customers. Examples listed there: Google Docs, FreshBooks, Salesforce, Basecamp, NetSuite, and Gmail. Again, there's so many different types of software as a service out there on the internet. These are just a few of the examples. Then you have platform as a service, and the people who are using that are developers. Developers who want to get their application up and running fast and have end users using it as fast as possible. So you've got Force.com, you've got App Engine, and Microsoft Azure. VMware even offers what they call Cloud Foundry. So there's a variety of different platform as a service offerings, but you're only going to be using one of those if you're a developer. Then we've got infrastructure as a service. The primary users of that, of course, are system administrators. Things like Amazon Web Services, GoGrid, Rackspace.com, and VMware vCloud and the vCloud data center providers. Again, 3 different types of cloud computing offerings here: software, platform, and infrastructure, each serving 3 very different end user groups. So now let's move on and talk about cloud terminology. My goodness, there's so many different terms related to the cloud, but there's only a handful that are probably completely new to you. We talked about infrastructure, platform, and software as a service. We'll talk about private, public, and hybrid cloud here in just a second. But in all these terms here, some of the most important ones I've laid out are listed here. They are scalable and scalability, elastic, elasticity, capacity, agility, tenancy, multi-tenancy, or tenant, security concepts, confidentiality, integrity, and availability. So these are the terms that I feel like you need to know at this point. Let's start off by talking about scalable or scalability. So if an infrastructure is scalable, that just means can it grow, and can it grow very quickly without too much trouble for the service provider, let's say, that created that infrastructure. So you would say, as an end user, is that infrastructure or is that cloud scalable? Does it have scalability? If I'm an end user, let's say that I'm in charge of the Olympics website. It happens every 2 years between the Winter and Summer Olympics, and during that, let's say, 2 or 3 week period, whatever it is, the number of users accessing the website for the Olympics just skyrockets, and there's millions and millions of people trying to get access to the website, watch the videos, and find out, who won the gold, silver, and bronze medal. That infrastructure needs to be scalable, and by the same token, it also needs to be elastic. So what elastic means is, well, just every 2 years, do you really need that sort of massive infrastructure? So that infrastructure has to be elastic, or it has to have elasticity to be able to stretch to support that many worldwide end users. Then when the Olympics are over, it needs to be able to shrink back down, just like elastic does, and return to its original size, just to provide, the standard number of worldwide visitors who are accessing the Olympics website when the Olympics aren't going on, which is drastically different from the number of people who are accessing the website when the Olympics is happening. So your infrastructure, your cloud infrastructure, it's going to be scalable as compared to your traditional physical data center where, let's say I need to add 100 new servers. Well, gee, that's going to take me at least a month. I'm going to have to spec those out, order them from Dell. I'm going to have to get that in. I'm going to have to add some more racks, some more UPS, some more networks, some more storage. It's going to take me a long time to get all these servers up and running. My infrastructure just isn't that scalable versus these massive cloud data centers, which are extremely scalable, and they have extreme scalability in comparison. They're also extremely elastic, so they can stretch out and then shrink back down. The cloud infrastructure is going to have the capacity that you need as an end user to provide the CPU, memory, network, and disk resources that your application is going to require. By having this cloud infrastructure, you'll gain agility, tremendous business agility, meaning you can react quickly. So let's say that you're a relatively small company now, but your product goes crazy, and everyone has to have it in the world, and your website is just being beaten down by the number of requests. Well, you need a scalable data center that's going to be elastic, that's going to have the capacity, and by having that, you'll gain business agility, meaning you can act quickly. You can spin up 100 new web servers to support the number of requests. That agility is going to give your business a competitive edge over the other businesses that simply couldn't do that because their data center didn't have the resources. So that's one of the things that you're trying to gain out of cloud computing is business agility, meaning you're going to have the ability to react faster than your competitors can, thanks to the cloud infrastructure that you've chosen. Some other terms are tenant or multi-tenancy. So in a public cloud infrastructure, that's a shared infrastructure, that service provider providing the infrastructure has multiple customers. Those customers, instead of calling them customers or end users, those customers are called tenants. So if you think of an apartment building, you've got one apartment building. It has, let's see, a shared water supply, shared electricity. It has shared physical infrastructure, meaning the building, the elevators, the stairs, the hallways. And then each tenant who lives in the apartment building, they have their own area, their own segment. And then each tenant that lives in the apartment building, of course, they have their own apartment. That's their own private area that no one else in the apartment building can go into. But they are a tenant of the apartment building. They are a secure tenant, let's hope, that their apartment is secure and their building is secure. So a cloud infrastructure needs to support multiple tenants. It needs to do it securely, and that way, this shared infrastructure can be used by more than one company. I mean, these massive cloud service providers, they're building a very large infrastructure to serve, thousands or hundreds of thousands of customers and virtual machines. They're going to support multi-tenancy. That's just a requirement of cloud computing, especially infrastructure cloud computing. So now let's talk about some security concepts, specifically CIA. And it's not the CIA, the Central Intelligence Agency in the United States that you might be thinking of. The security concept as it relates to CIA is confidentiality, integrity, and availability. These are three core security properties. Your cloud infrastructure must have confidentiality. In other words, it needs to keep your data secure from other people who are using the same shared infrastructure in the cloud. Your data must be kept confidential. It also must have integrity, meaning it must not be lost, it must not be corrupted, it must not be manipulated or changed in some way without your knowledge. And then it also has to have availability, meaning it has to be there when you need it. It can't be stolen. The array that it's on can't be just down. It can't be very slow to be accessed. It needs to be readily available. So these three core security concepts not only apply to traditional security or network security, but they also apply very heavily to cloud computing. So make sure that the cloud infrastructure you choose is scalable, elastic, has the capacity that you need. It's going to give you business agility. It must support multi-tenancy, and it also has to provide you the security that you require, the confidentiality, integrity, and availability for your data. Now let's move on and let's talk about how cloud computing requires a new approach, specifically to IT management. Now, one of our terms that we covered was agility or business agility. Right now, it's very likely that your company's agility is suffering because of the way that traditional IT management is done. In that traditional IT management approach, services and assets are tied together in a complex, brittle, vertical stack that's very hard to change and very hard to manage. In other words, in your company in the past, if you were putting in a new CRM application, a customer relationship management application, most likely you would buy a new SAN for that, a whole new cluster of servers, network. You might even have to add new end user devices. Maybe there's a big fat client that runs on some hefty PCs for some power users. And these vertical stacks were built over time. They're very difficult to change, they're very difficult to replace, and they don't adapt quickly when new applications are brought in and new services are required by the business. With cloud management, IT will finally be able to keep up with the speed of the business and provide the business what they need when they need it. That's thanks to the new agility offered by cloud computing. With cloud management, this new approach to IT infrastructure, you've got service components that are abstracted and sourced from dynamic pools of resources with horizontal layers loosely bound to services. That's in comparison to this rigid traditional IT management infrastructure with the complex, brittle stacks that are hard to change and hard to manage. With cloud management and cloud infrastructure, IT can use this shared pool of virtual resources. It's scalable, it's elastic, and it can provide the applications that the business needs when they need them, and you can access them from whatever device you want from wherever you are. Another point I want to make here is that cloud computing as a whole requires IT people to think differently. to break free of the traditional rigid IT services models and think differently. And we'll be talking much more about that in upcoming lessons. Now, earlier in the lesson, when I talked about the different types of cloud computing, I covered infrastructure, software, and platform as a service. I said there were other forms of something as a service, and one of those is IT as a service. Now, IT as a service is just as much a cloud computing model as it is a new business model for you to adopt. And this is being adopted by more and more businesses because, businesses today have much more strict demands on IT. They have greater expectations out of their information technology department. IT needs to be, like I said just a second ago, a business differentiator, and one way that they do that is by looking at themselves as providing IT as a service. So IT as a service is a combination of efficiency, where you do a better job of governing cost and you get the most from your resources, and a combination of agility, where you anticipate and respond to changes or the needs of the business. And both of these are going to provide your business a competitive advantage. With efficiency, you can gain the right service at the right price. With agility, you can gain the right capacity at the right time. So even if you work for a privately held small and medium-sized business, you're not at a service provider, but try to look at yourself as being a consulting company and a service provider where you have to put a value on everything you do. You have to put an hourly rate on everything you do. And if you look at yourself that way in the IT department, you'll start to become more efficient and help the business to become more agile. Try to focus your time in on things that are going to provide the greatest business value for your company and the greatest competitive advantage. And that's really the reason that companies are adopting cloud computing more and more, is because they believe it's going to give them agility and a competitive advantage, and they'll be able to gain that by breaking away from those traditional IT service models than the traditional inefficient vertical silos that are linked to specific applications. Now let's move on and talk about private, public, and hybrid cloud computing. So the first thing that people think of when they think of public clouds, especially infrastructure as a service clouds, are, let's say, hosting companies or service providers out there that give you access to one or more virtual machines that you deployed quickly from a catalog, and then they sell you that access based on an hourly rate or the amount of resources that those virtual machines use. That's the typical public cloud model. But there are other forms of cloud. So let's take a look at private clouds. A private cloud would be your typical private company. They've got, let's say, a data center. They're using virtualization. And on top of that, they load a cloud director that creates this private cloud infrastructure. So the cloud director offers the same benefits. It offers self-service. It offers multi-tenancy. You might be thinking, wait, I don't have multiple tenants. I'm just one company. I'm not a service provider. Well, in many larger companies, they have different divisions. They might have a production group, a development group, and then a European group or an Asian group, or they could break this cloud infrastructure up, their own private cloud infrastructure up, into different continents or different business divisions or different business types, like manufacturing versus retail versus development. This private cloud can be broken up however they need to break it up. The tenants can be defined by them, but the point is that the tenants can use that same self-service model to roll out the applications that they need. They can have the scalability, the cloud can be elastic, it can give the business agility, and then the cloud's also going to offer chargeback or even showback to show those tenants the amount of resources that their virtual machines and applications have consumed. So there are great benefits to utilizing private cloud computing just as much as there are to using public cloud computing. Now in the middle, you've got what they call hybrid cloud, which is really just a combination of the two. So if we go back to that example, let's say with the Olympics, they only need to spin up this massive number of thousands of web servers, every couple years. They might be using a private cloud to host their everyday, common web infrastructure. They manage it themselves. They have multiple tenants still, like development and production, and maybe a retail store tenant. And then when it comes time for the Olympics and they need, thousands of web servers, they could use a hybrid cloud model. So they could spin up those web servers over in the public cloud, and then they're connected together, typically by a WAN circuit or a VPN tunnel, through the internet, and actually these clouds can work together. That's right, the virtual machines in the private and the virtual machines in the public cloud, they can all work together just as if they're on the same network in the same data center at your own location. Of course, we'll be talking more about private, public, and hybrid cloud throughout the course, but these are important concepts and terms to understand at this point in our Cloud 101 lesson. Now, when it comes to moving to a public cloud infrastructure, there's a long list of concerns that you're going to have, and really you should have. Most of these are related to trust. I mean, you're entrusting someone else with your company's critical data and applications. So the first question you're going to have is, where's my data? I want to see my data. I want to see the hard drives, that it's on. I want to see the servers that make up my cloud infrastructure. I want to see the data center. I want to know what city it's in. I don't want it moving, to some other state or some other country even, or halfway around the world. I want to know where my data is. And your provider should be able to tell you that to some degree, depending on the level of cloud computing service, that you have contracted with. What about data loss? What if my data is gone? Is it backed up? Can someone restore it for me? Can we test restores? How do I really know that my data is going to be available all the time and that you're going to take good care of it? That it's not going to get stolen or hacked? It's not going to be posted out on the internet? Of course, these are all valid security concerns that a provider needs to address for you. And then there's cost. Can I do it cheaper than you? I've been doing this for a long time. It's my data, my servers, my storage arrays, my users. IT admins typically have the opinion that, hey, I can do it better. I've been doing it for a long time. And certainly you don't want to discount the experience of these large service providers. I mean, they've been doing this in massive scales for many years. So they might have, tremendous efficiencies to offer you that can actually save you time and allow you to invest that time into something that can actually make the business money instead of just keeping the servers up. On the other side, you may be able to do things less expensive or at a lower cost, but can you actually do them better? And what if your business grows quickly? If you're a very small IT shop, what if you need to deploy, 200 new web servers by the end of the week? Many shops just don't have the resources when they're faced with tremendous growth. On the other hand, what if you did deploy those web servers and then a year from now you need to eliminate them or get rid of them? If you're an IT shop, even just the idea of decommissioning, 200 or 250 servers is going to be a tremendous, undertaking. So think about the elasticity of these clouds, how it's a utility computing service, and you're only paying for what you use. There's a lot of benefits related to that. You can also consider a hybrid cloud scenario where you've got a private cloud connected to a public cloud, but with that, you could have poor performance. So if you're looking at a hybrid cloud computing scenario, you need to ensure that you have solid network performance between your private cloud and your public cloud. You could just have performance and capacity concerns in general, kind of like a shared internet cable networks where, your neighbor comes home at 5 o'clock and starts downloading movies over the internet, and it slows down your home network because you're both accessing the internet through the same physical cable that's in the ground. Well, public cloud infrastructures can suffer the same problems, and they call it the noisy neighbor syndrome. So you don't want to suffer from those types of problems. You need to address these concerns with your cloud provider. You can't just be uncomfortable in general with the idea that, hey, right now I can look in the data center and see my servers. When I move them to the cloud, I can't see them anymore. What's happened? Am I going to lose control of these servers? Am I going to lose my job? Am I, essentially outsourcing what I do to someone else? You have to look at it this way. Look at it as this is a good thing, actually, because now you're free to provide real business value. You don't want to just be, like the hen who has to sit on the eggs, and that's all you do. You don't want to have to just sit in the data center and take care of the servers. Let that job go to someone else who can do it better, more efficiently, at a massive scale. Only pay them for what it is that they do, and then you take your time and do the projects for the company that are actually going to increase profits, increase revenue, and show real innovation. I mean, odds are, if you look at yourself as an IT professional, you're not going to get a raise just by keeping the servers up. I mean, people expect the servers to be up all the time already. Chances are you're going to get in trouble or fired if the servers go down. a much better job for you would be to get a raise by being innovative and showing real business value for the company. Help the CIO, help the CIFO, help the chief marketing officer, help the manufacturing division to be more efficient, save time, and produce more. That's the role that IT needs to undertake once they've moved to cloud computing. So again, these concerns related to cloud computing are all very valid. They're all to be expected, and we'll be addressing these, throughout the course. All right, we talked about an infrastructure as a service cloud. So, that might be a hosted virtual infrastructure with a bunch of other things on top of it, like self-service and chargeback. But what's actually inside that infrastructure as a service cloud? What really makes that thing tick? Well, first off, that infrastructure as a service cloud needs to be 100% virtualized. You're not going to have traditional physical servers with a single Windows operating system with a single application and database on top running inside an IaaS cloud. You're going to have physical servers with a hypervisor on top and all the virtual machines on top of that. It's going to be 100% virtualized. That's required so that you can do things like hardware independence and move a virtual machine from one host to another, move a virtual machine down to your private cloud, and clone virtual machines to very quickly roll out a massive number of virtual machines in the cloud. So it has to be 100% virtualized. It must provide a self-service portal of some kind for you to roll out these new virtual machines, to create virtual networks, virtual data stores. That self-service portal is going to be your interface to your new virtual data center in the cloud. The self-service portal will give you the catalog of virtual applications. Within a few clicks, you can roll out, applications that used to take months to get up and running. Things like Exchange, SQL Server, Oracle, SAP, web servers, and so on. The infrastructure as a service cloud must offer some sort of service level agreement with the business if it's a private cloud, or with the tenants or end users if it's a public cloud. So the self-service agreement is going to define the expectations. How many virtual machines, can I roll out? How scalable is this cloud? What's the penalty if the cloud is down? What's the acceptable latency for this tier of service? What are my various tiers of service? How much am I going to pay for that? That would likely be in the contract. The service level agreement is going to primarily focus on security, availability, and performance. The infrastructure as a service cloud is going to offer flexible resource pooling. That's going to be provided by the virtual infrastructure. For example, with vSphere, they have distributed resource scheduler, which is a feature that effectively offers load balancing across all the physical hosts in the cloud infrastructure, such that if one virtual machine needs many more resources that day than it did the day before, it can be moved to another host where it can get those resources. It needs to offer high availability, such that if a physical server fails, those virtual machines are brought back up either immediately with no downtime, or with very minor downtime. And of course, that would be detailed in the service level agreement, or the SLA. The infrastructure as a service cloud must also offer automation. Things need to be automatic. The virtual infrastructure needs to be backed up automatically. You don't need to be worrying about that as an end user or a tenant. Of course, high security must also be enforced to support the multiple tenants that are sharing the infrastructure as a service cloud. Whether or not it's a private or a public cloud, it needs to have high security and support the multiple tenants who are using it. It should have resource reporting and billing so that you can define who's using what resources in the cloud. And if it's a public cloud, you would want to bill back, those resources to those tenants and have them compensate you for the resources used from your cloud infrastructure. It's also going to require a change in the way that you think about IT. It's going to allow you to do things faster, but you're also going to have to put faith and trust in your cloud service provider. You'll need to educate the business to help them change the way that they think about IT. Certainly they'll be happier if they can get the services and the applications that they need faster, but on the other hand, they also need to keep in mind that it's very likely that the more that they use, the more that their business unit will have to pay for that. Now, while we're talking about infrastructure as a service clouds here and what makes them up, I should also point out that software as a service and platform as a service cloud infrastructures are going to run on top of this exact same type of infrastructure as a service cloud. But instead of the end user being a tenant and having access to a self-service portal and their catalog of applications and their own resource reporting and billing, they're going to be given a web interface or a development infrastructure so that they can utilize that to build their application or use their application. But underneath this concept of being 100% virtualized, shared infrastructure, high availability, high security, all these same concepts are going to be used with the software as a service or platform as a service running on top. So I know we've talked a lot about virtualization, but I want to take a moment to point out that server virtualization is required for cloud computing. It doesn't matter the type of cloud computing, whether it's infrastructure, software, or platform, they're all using server virtualization underneath. It is the infrastructure that the cloud is built on top of because it offers that scalability, that elastic computing, resource sharing, pooling, load balancing, high availability, the hardware independence or the portability of the virtual machines from private to public and public to private, and then from one public cloud to another public cloud. Virtualization offers that. It also offers the cloning so that you can roll out new virtual machines with new applications with just a few clicks of the mouse. So server virtualization, hypervisors like VMware vSphere, Microsoft Hyper-V, Citrix XenServer, all these are loaded on top of physical servers in the data center to create a virtualization layer. And then on top of that is the cloud infrastructure. So a cloud director like VMware vCloud Director is just one example of cloud infrastructure that you would load. Then you would also take advantage of a chargeback or reporting software, and then security features to ensure that the cloud infrastructure is highly secure and can support the multiple tenants. So server virtualization is required for cloud computing. It is the foundation for the cloud. So keep that in mind. And that brings us to the summary for this lesson. We started off by answering that tough question, what is cloud computing? And I think it's best defined by the various forms of cloud computing that are in use today: platform as a service, software as a service, infrastructure as a service, and others. From there, we covered cloud terminology and how cloud computing requires a new approach to information technology. You're going to really have to give up some control and put trust in a service provider in return for the benefits of cloud computing. We defined private, public, and hybrid cloud computing before discussing some common concerns that you probably have about cloud computing. After that, we covered what makes up an infrastructure as a service cloud. It's really built on the traditional data center components of server, storage, and network, as well as a virtualization layer, and then a cloud director layer that really enables the infrastructure as a service cloud functionality, things like software as a service, an application catalog, resource pooling, and chargeback or showback. Finally, we discussed how cloud computing is related to virtualization. Virtualization is really the foundation that cloud computing is built on top of. Thanks for watching this lesson covering Cloud Computing 101.